Hello everyone. In this session, I will be explaining about AWS Elastic Container Services and I will be covering all these topics, that is what is AWS Elastic Container Services, why we need it and its key features and what are its architecture, how the things will work, and let's understand the ECS versus other orchestration tools. At the last, I'll show the practical session on this AWS Elastic Container Services. So let's go and understand everything clearly. So what is AWS Elastic Container Services? So, it is a fully managed container orchestration service that simplify the process of deploying, managing and scaling containerized application. So, it designed to work seamlessly with a Docker containers. ECS allow developers to run applications in a distributed environment with the minimal infrastructure management, and also it integrated tightly with the AWS services like Elastic Load Balancing, CloudWatch, identity and access management, and auto scaling, ensuring high availability, security, and performance. And it also offers two deployment options. One is Fagrate, it is a serverless model where AWS handles infrastructures, everything, and ECS, where users can manage their own compute resources with its scalability, reliability, and integration with the AWS ecosystem. ECS is an ideal choice for running modern application, including microservices and batch jobs. So let's understand why it is so it's a powerful choice for container orchestration because it simplifies the deployment, scaling, and management of containerized application while leveraging the robust AWS environment. And also, it's integrated with the AWS services like IAM for secure access, CloudWatch for monitoring, Elastic load balancing for traffic distribution, making it an ideal platform for running scalable and highly available application. And also users can choose between the serverless flagrant option, which eliminates the need to manage infrastructure, or another option EC2 for greater control over the compute. So, and it is a pay as you go pricing model, ensuring cost efficiency while featuring like auto scaling and multiple availability zone supports provide reliability and performance. And it's particularly well suited for microservices architectures, batch processing, and CI/CD pipelines. Offers a comprehensive and flexible solution for modern application needs. So let's understand the key features of AWS ECS. So in this first thing we have is a fully managed. The AWS Elastic Container Services is a fully managed services, which means AWS take care of the underlying infrastructures, scaling and management tasks. So these allows developer to focus on creating and deploying containerization applications without worrying about hardware clusters, management or scaling. It significantly reduces operational overhead. Flexible deployment. Flexible deployment options. So in this we have two modes. One is Fagrate mode, another one is a EC2 mode. So with Fagrate, you don't need to manage or provision any EC2 instances. AWS automatically handle the infrastructure, scaling and provisioning of resources. You only pay for the compute power, that is CPU and a memory your containerized consume. So this is a serverless option, ideal your application with variables or unpredictable resource needs. So when it's come to the EC2 mode, you can deploy or containerize on EC2 instance, providing more control over the underlying infrastructure. You are responsible for provisioning and managing EC2 instances, which may involve setting up instance type, managing scaling and optimizing the cost. This mode is better for workloads that needs more control over a specific customization. So the next we have is a tight integration with AWS ecosystem. So in this we have a identity and a access management. So it's integrated with IAM, allow you to create fine-grained security policies to control access to ECS resources and other AWS services. And it also have the CloudWatch. It's integrated with the CloudWatch for monitoring container logs, resource usage, and application performance metrics. CloudWatch help ensure visibility into the operation of your ECS tasks and services. And it also have a elastic load balancer. It also integrated with the load balancer to distribute incoming traffic evenly across multiple container running in a ECS, ensuring high availability and a fault tolerance. And it have a auto scaling ECS and automatically scale the number of tasks running in the response to the load changes, helping ensure our application remain responsive under varied traffic condition. I already explained it is integrated with the IAM, CloudWatch, Elastic Load Balancer, and auto scaling. So that is what I'll explain now. So the next feature we have is a high availability and a scalability. So when it's come to its high availability, so it's a multiple availability zone deployment. ECS tasks can be distributed across multiple availability zone to provide resilience and minimize the risk of service interruptions. If one availability zones go down, ECS will automatically shift tasks to healthy availability zones. And it also have the auto scaling features, can dynamically adjust the number of running tasks based on the pre-configured scaling policies, helping ensure that your application scales up or down in the response to the actual demand. So this makes ECL ideal for variable workloads and fluctuating traffic patterns. The next feature we have is a task definitions and a services. So when it's come to its task definitions, ECS uses task definition which describe how containers should run, including the Docker images, CPU, and a memory resources, environment variables, network settings, and a storage. Task definition can be reused across services and the cluster, making them an essential part of ECS automatically and automation and scalability. When it's come to its services that ensure the desired number of tasks are always running. If task fails, the service will automatically restart it to maintain the specified task count. ECS service can also integrated with the load balancer to ensure that incoming traffic is distributed evenly across the task. So next feature we have is a custom network and a load balancing. ECS can be configured with the advanced networking operation. Tasks can be used AWS VPC networking mode to receive their own elastic network interface and a private IP addresses, making them directly accessible from other AWS services or the internet. ECS integrated with the application load balancer and a networking load balancer, allowing user to distribute traffic across containers efficiently and manage load balancing based on the application specific requirements, that is HTTPS for application load balancer, TCP for network load balancer. So the next thing we have is a elastic container services architecture. So in this we have main component. In main component we have a task. The task is the core unit of work in AWS ECS. It defines the blueprint for running containers, including the Docker images to be used, the CPU and memory allocation, environment variable, network configuration, and storage option. Tasks are launched from task definition, which specify all the required parameters for the containers. Each task run on a specific number of containers and operation in isolation within the ECS cluster. And the next main component we have is the services. ECS services manage the long running instance of tasks. They ensure that the desired number of tasks are always running across the ECS cluster. Even if some tasks fail, service can also integrated with elastic load balancer to distribute incoming traffic and multiple tasks across multiple tasks, enable high availability and scalability with auto scaling capabilities. ECS services can dynamic adjust the number of running tasks based on the traffic and workload demand. So the next main component we have is a cluster. It is a logical grouping of resources that task and the service are run on. Cluster can include one or more EC2 instances or use AWS Fabric for serverless execution. Each cluster can support multiple application and user can define separate cluster to isolate workloads. So in this we have a modes of operation. You already know that Fabric mode and a EC2 mode. So when it's come to a fag rate mode, in the serverless mode, AWS manage the underlying infrastructure. Users only need to define the containerized configuration and do not have to provision or manage EC2 instances. Idle for items looking for reduced operations overhead and focus slowly on application deployment. Costs are based on the CPU and memory usage, offering a straightforward pricing model. So when it's come to EC2 mode, in this mode user provision and manage their own EC2 instances within the cluster, provide greater control over the instance type, operating system and a network configuration, and it is suitable for application requiring fine-grained customization or a cost optimization using EC2 spot instance. So this is the how the architecture will work. So let's understand how ECS will work. So first it define a task definition. So it's act as a blueprint for your application, specifying how your containerized workload will run. It includes Docker image, resource allocation, network configuration, environment variables, and volumes. So these task definition can include multiple containers, allow for sidecar patterns where multiple containers work together, such as an application container alongside a logging or a monitoring container. So create a cluster. So a cluster is a logical group of resources where ECS tasks and services run. If using EC2 mode, the cluster includes a group of EC2 instances registered with the ECS. If you are using Fabric mode, the cluster use AWS manage resource, eliminating the need to provision EC2 instances. Cluster help organize workloads and enable efficient resource sharing while providing isolation for different applications or environment. So the next how it will run, the third step is run task or a services. Once the task definition and a clusters are ready, you can run a task, launch one time or a batch processing workloads. Tasks are temporary and stop after completing their work. Then run services, deploy long running application services, maintain the desired number of tasks instance and provide load balancing for high availability. ECS ensure that the task and the services are distributed across multiple availability zones for reliability. And next is monitor. Fourth step, it integrated with the Amazon CloudWatch, enabling monitoring and logging for task performance, that is CPU, memory, and network metrics, service health and availability, logs for debugging and troubleshooting applications issue. Additional tools like AWS autoscaling can dynamically adjust the number of tasks based on CloudWatch metric, ensuring our application scale efficiently to meet the demand. So this is the things the we have four step. These four step will work with the elastic container services. So let's understand ECS versus other orchestration tools. So the first we have is a um, managed, how it will managed for ECS, Kubernetes, and a Docker Swarm. So when it's come to its AWS, it's a fully managed service by AWS, meaning AWS take care of the underlying infrastructure, scaling and cluster management. User only need to define their task and services without worrying about setting up or maintaining complex systems. So Kubernetes, it's a partial managed. AWS manages the Kubernetes control plane, including high availability and scaling of the master node. However, user can responsible for configuring and managing the worker nodes, EC2 instances or a fabric, and ensuring their applications are properly orchestrated. So Docker Swarm, it is self-managed, required user to set up and maintain the infrastructure, including all nodes in the cluster, networking, scaling, and a fault tolerance. It provides simplicity but places operational responsibility entirely on the user. So when it's come to its AWS, it is fully managed, and Kubernetes is a partial managed, and a Docker Swarm is a self-managed. So the next thing we have is a complexity. So AWS ECS is designed for a easy of use, especially for developers already familiar with AWS. It provides a simple interface for creating cluster, defining tasks, and running services. Make it a great choice for small to medium projects. So Kubernetes has a medium complexity due to its advanced features like custom resource definition, service mesh, and fine-grained control over orchestration. So it requires a step learn curve, but it's a powerful for large scale and a multi-cloud or hybrid cloud deployment. So Docker Swarm is a low complexity, focusing on simplicity and a easy of setup. It is intended for teams already using Docker, and it's suitable for lightweighted application that does not need extensive orchestration capabilities. So when it's come to its ECS, it easy to use. Kubernetes in it is a medium, and Docker Swarm as a low complexity. So the next differences we have is a integration. So ECS has deep integration with AWS services such as IAM, CloudWatch, Elastic Load Balancers. So when it's come to its Kubernetes, it has a multi-cloud environment, meaning it can be deployed on AWS, Google Cloud, Azure, or on-premises. So when it's come to its Docker Swarm, it's mainly focusing on Docker based tool. It does not provide built-in support for major cloud provide services. So you can choose AWS ECS for simplicity, AWS native applications, and a seamless services integration. When you opt for Kubernetes means if you need advanced orchestration for multiple cloud or hybrid environment, then you can go with the Kubernetes. Use Docker Swarm for lightweighted application requiring minimal setup and management. Then you can go with the Docker Swarm. So let's understand the pricing of this. So when it's come to the favorite mode, you pay only for the CPU and memory resources used by your running task and services. There no need to provision or manage EC2 instances, so you avoid infrastructure related cost. So pricing is calculated based on the CPU hours, memory hours. So these serverless approach simplify the cost management, and it is ideal for applications with unpredictable or a bursty workload. So the next pricing we have a EC2 mode. You can pay for the EC2 instances used to run your containers as well as any additional AWS services such as storage and networking. So costs depend on the EC2 instance types, the number of instances in the cluster, and their runtime. You have more control over the infrastructure, but you must manage optimization it yourself. So save steps. So these reduce cost in EC2 mode. You can use spot instance which are unused EC2 capacity offered at significantly lower rate. Spot insurance are best for fault tolerance or a flexible application. Auto scaling group and ECS can automatically replace the interpreted spot instance with new one. So when it's compared to the flag mode and a EC2 mode, so when it's come to its flag mode, it's a simple pricing, great for unpredictable workloads. So EC2 mode, more control, potential for cost saving with spot instance or reserve instance. So this is about the pricing concept. So I'll cover all the topic in a theoretical part, and I'll show you the demonstration of the AWS elastic container services. So let's move to the AWS account. Let's demonstrate things. So let's start with the practical session of Elastic Container Services. So let's navigate to the Elastic Container. Once again, I'll change to my region. So see, Amazon Elastic Container Services is a fully managed container, and it's highly scalable and a fast container management service that make it easy to run, stop and manage container on the cluster. So you can see your pricing on ECS, AWS, Fagrate. So let's see the serverless Fagrate the pricing. Mm, okay. So per CPU per hour, it will showing 0.04 something dollars, and for GB per hour it's showing 0.004445. It's showing this is the pricing of the Fagrate, and Fagrate is a serverless, right? um, and also you can also see the EC2 pricing also. Yes, we have two types of Fagrate types, right? That's why I'm showing those things for you. So for EC2, it's not showing. So let it be. So let's get started. And the first thing what we need to do is we need to create a cluster for this. So click on create cluster, and give the name. So I'm giving web application. See in the infrastructure, you can your cluster is automatically configured for AWS Fabric, that is serverless with two capacity provided, and Amazon ETOS instance. So if you want serverless, you can go with the AWS pay as you go. If you have tiny batch, everything it has. So if you want to go with the EC2 instance, you need to manually configure all those things. I'll keep it as default one, that is for Fagret. So the name I have provided. So click on create a cluster. So this will create a cluster for us. So the cluster web application creation is in progress. So see, services zero, task no task running, container also zero. So if you go inside the web application, so you can see, and as of now we have don't have any services, or we don't have any tasks. So let's go and create a task definition first. So go to task definition. So click on create new task definition. So create new task definition. So here we need to provide the name, task definition name. So I'm giving web application OPD, and in the infrastructure requirement, I'm keep it as same, that is default Fagrate mode. So 3GB, let it be. That is the default one. In the operating system, you have several types of operating system. You can go with the Linux only, and the rest of the thing will be default one. So here we need to create a container. So for that, what we need to do is go to the Chrome and search for Amazon ECR public gallery. So if you enter this, you can see with several things. So here we need a Nginx. So if you go to inside this, we can see the URL of this Nginx URL, and can provide the name here. For the container detail, we are giving the Nginx name, and we need to provide the image URL. So copy this URL and paste it here. Mm, this is the container we are creating, so that's why I am taking the nginx name and the image URL I have taken. So they see the port mapping, container port map is 80. So and the rest of the thing will be same. The rest of the thing will be same. So click on create. So it will create a task definition for us. So see, the task definition has been created, and now what we need to do is go to the cluster. So refresh, come to services. So go inside the task definition and you can see the deploy option. So or else you can go with this, and yeah, you can deploy this thing, deploy and create services. So here the environment in which the existing cluster, the web application, and the compute option will be the default, and the capacity provider is the frag rate. So and the so you can see the task destination family is the web application that we have created, and we need to provide the service name here. So I'm giving nginx service. So when you scroll, the desired task is the one, and in the network section, so see it will take on the VPC security, and here we need to create a new security group. So the security group I'm giving us container security group. And the description I'm giving is security group for Nginx container. and we need to add the rule. So here only I'm taking as, so search for HTTP and its port number is 18 and custom, so it will taking as anywhere. So this is the rule I'm giving. So scroll down and create. So Nginx deployment is in process. It's take a few minutes. So let's wait. So see, the service name has been activated and the task is in a provisioning state. So when you go inside the services, so you can see the health of the metrics and all. So we can see the health of the CPUs and everything. If you go to the task, you can see the task utilizations, everything. Logs, you can see all logs also. What logs the Nginx, it's showing the creation of the process. So everything it will showing on cluster. So still its deployment is in progress. So let's wait a few minutes until the deployments gets completed. Still the task is in a pending state. So yes, now it has been, it's showing running, but still in this it's showing it's a pending. Let's wait. Still it's showing like this only. So if you go inside the task, still desired status is running. So let's wait. And also we can see the operating system, what the CPU we have taken, and the launch type we have using it's a serverless, everything. So if you, so copy the public IP address and paste it in the Google. So let's see whether the Nginx page is so no, still it's not completed. So let's wait another few minutes. So go with the open the address. So see the welcome to Nginx and it's accessing through the web. So this is how the elastic container services will work and the demonstration of ECS. So let's go and delete the resources what we have been created. So the first thing we need to delete is we need to stop this task. So click on stop. First step we need to stop the task. Then um, cluster we need to delete this server. Force delete. Click on delete. So the service has been deleted and the cluster is stopped. And now what we need to do is we need to delete the entire cluster. So click on delete. So delete web application. So see, service deletion, container instance register, and a cluster and stack of deleted. So now it has been, there is no cluster. So go to the task definition and see the task definition is an active. So we need to register this. So click on deregister. So see, the successfully deregister. So this is how the things will work. And the at the last, please delete the resources what you have been created. So that's all about the elastic container services. Thank you.